Have you ever held a bullet and wondered, how does something so small carry so much power? What kind of machines, steps, and science go into making a single round of ammunition? Today, we're diving deep into the highly precise and fascinating process of bullet manufacturing, step by step, straight from the factory floor. Every bullet starts its life not as a weapon, but as a simple sheet of metal. Large, heavy rolls of brass, an alloy made from copper and zinc, arrive at the ammunition factory. These rolls are strong, durable, and flexible enough to withstand high pressures. They're uncoiled and fed into a machine called a blanking press, which punches out hundreds of small, flat brass discs every minute. Each of these discs is smooth, identical, and slightly bigger than a coin. These are the raw blanks that will be turned into the shell casings we see on every bullet. But a flat disc isn't much use on the battlefield or at a shooting range. The next step is to give it shape. These discs go into a cupping press. Here, a powerful steel die presses into the metal, turning it into a shallow cup, similar to pressing your thumb into dough. This is where the transformation truly begins. That shallow cup will eventually become the cartridge case that holds the primer, propellant, and bullet. Once formed into cups, these brass pieces go through a process called drawing. Drawing is exactly what it sounds like. It stretches the metal in multiple steps. Each cup is drawn through different presses that pull and stretch the brass until it's longer, narrower, and thinner. The walls of the cup become slimmer while the base remains thick and strong. This results in a tube-like case, and after a few passes, it starts to resemble a real bullet casing. Now comes the precision engineering. The case head, the bottom part of the casing, needs two critical features: a primer pocket and a flash hole. The primer pocket is a small, circular indentation at the bottom where the primer will be seated. Using special tools and immense pressure, a machine forms this pocket with extreme accuracy. Immediately after that, a laser-guided drill creates a tiny hole through the center of that pocket, the flash hole. This flash hole is crucial. When the primer is ignited, the flame travels through this small hole to ignite the gunpowder inside the case. It may seem like a minor detail, but this tiny hole must be drilled to micrometer precision to ensure consistent ignition and performance. Now, the metal has gone through intense shaping and forming processes. All that squeezing, stretching, and pressing makes the brass harder and more brittle. To restore its flexibility without losing its strength, the case goes through a thermal treatment process known as annealing. The brass is slowly heated in a furnace to a precise temperature, high enough to relieve internal stress, but not hot enough to melt it. Just as important as the heating is the cooling. The brass is cooled in a controlled environment, allowing its grain structure to return to a more flexible state. This balance between strength and ductility is what allows the final bullet to withstand firing pressures without cracking or deforming. With the cases now soft and strong in all the right ways, it's time for final forming and cleaning. The cases are trimmed to the correct length, cleaned with special that ignites when struck. In automated machines, the primers are seated perfectly into the primer pockets made earlier. This must be done with care. Too loose and it may miss fire. Too tight and it might deform. Then comes the step most people recognize: the addition of gunpowder or propellant. Using precision dispensers, each case receives a carefully measured amount of powder. This amount is exact, down to fractions of a grain, because even the smallest difference can affect how fast the bullet travels, how much pressure is created, and how accurate the shot is. After the powder, it's time for the bullet itself. Made of lead, copper, or a combination of metals, the bullet is the part that gets fired from the weapon. Machines place each bullet into the mouth of the casing and seat it to a specific depth. This depth is critical. It affects chamber pressure and the bullet's flight path. Once seated, the case is crimped, meaning the mouth of the case is tightened around the bullet. This locks it in place and ensures it doesn't move during handling or firing. Crimping is often overlooked, but it's essential for safety and accuracy. A loose bullet could cause malfunction. A tightly crimped one ensures consistent performance. Now, it may look like a finished bullet, but the process isn't over. Every round must be inspected. First, automated systems equipped with high-resolution cameras and laser sensors check each bullet for visual and dimensional accuracy. These systems scan for misaligned primers, damage tips, uneven crimps, and inconsistent measurements. Then, human inspectors step in. They conduct visual checks, field tests, and even live fire tests from sample batches. This is called quality assurance. They ensure the bullets meet safety standards, legal requirements, and performance expectations. If even one round shows a defect, the entire batch might be reevaluated. Failed bullets are not simply thrown away. In most factories, they are sent back for recycling. The metal is melted down and reused in future production, minimizing waste and maintaining sustainability. Once the bullets pass inspection, they are sorted, counted, and packaged. Robotic arms place them in trays or boxes with high-speed precision. Each box is labeled with the caliber, batch number, manufacturing date, and factory code. This level of detail allows full traceability from raw material to final product. But the story doesn't end at the packaging table. Factories must maintain strict regulatory compliance. Every process is documented. Wastewater from cleaning is treated before release. Emissions from furnaces are filtered through scrubbers, and all scrap material is recycled. Factories are routinely audited to ensure environmental, health, and safety standards are being met. Now, take a moment to think. This tiny object in your hand, whether it's for self-defense, sport, or military use, has gone through dozens of machines, steps, and inspections. Every part of it, primer, case, powder, and bullet, was created with precision down to fractions of a millimeter. It's not just a product, it's engineered performance. One small mistake in this process could result in a misfire, a jammed weapon, or worse, injury or death. That's why ammunition factories follow strict guidelines and treat every round as if it's the one that matters most. Because when the moment comes, it will matter. In the end, the bullet you see is simple on the outside, but behind it lies metallurgy, physics, chemistry, engineering, and automation all working together to deliver one job: reliable performance every single time. And now you know how a bullet is made, from brass coil to the box in your hand. This is Evoke. If you learned something today, consider subscribing and turning on the notification bell. What should we break down next? Comment below with a process you want to see exposed and explained. Your feedback shapes our next documentary.